in the area of watershed, there are increasing population activities. There are land use, changing land use, and this is affected to the two of this watershed. And in this analysis, we analyze to the correlation between regime river coefficient and runoff coefficient in the two of Sidutan and watershed. The use of the coefficient to the watershed, to the river regression, to the groundwater runoff is needed to see the condition of a watershed, whether there still has a level of flood security that is moderate or very heavy. And in the analysis of the REA watershed and Sidutan watershed studies, it is necessary to observe the rainfall and data points called rainfall station or flood discharge data observation station called automatic water level recording to get actual coefficient value of the two watersheds. In addition to the C value, the watershed condition can also be known by using the river regression coefficient, or we also call a river regime coefficient value, where the value of this RRC or KRS is a number which denotes the ratio between the maximum daily average discharge with the minimum daily discharge in a hydrological year. This is the data of two main watersheds in the northern of Lombok. The first is Sidutan watershed. The area is 37.77 kilometers squares, and we have a station here named Santong, and the main river is Sidutan River. And the second is Reak watershed, the area of 33.66 kilometers squares, and we have station here, call it Sopak, and the main river here is in Reak River. A regime river coefficient and runoff coefficient is obtained from these two watersheds by this data. This is the figure of a Sidutan watershed in the left and then Reak watershed in the right. In this methodology, we have a data record, that is watershed topographic maps, an hourly of automatic water level recording, and hourly rainfall data. And from this required data, we analyze this data. This is rainfall data, the discharge data of automatic water level record, the value of runoff coefficient, and the last is the relationship between regime river coefficient and runoff coefficient. This is a very important thing in this analysis, is the relationship between regime river coefficient and the runoff coefficient. In this next figure is the chart of hourly discharge and rain from the year of 2011 and 2012. This in the Sidutan watershed from the station of Santong. Here is the station of Santong, and this This one in the right hand is in Reak watershed, and the data is from the Reak station. And this is the hydrograph discharge from 31 of October until and 14 of November. This is in Santong station, and this is not Reak station, but this is Sopak station. Reak is the name of the watershed, but the station called it Sopak station. This is the recap of the Zim River coefficient and coefficient of runoff values per year of Sidutan and Reak watershed from October to September 2011 and 2012 until 2016. And the last, this is the relation between, from the calculation, we obtained the relation between referencing coefficient with coefficient of runoff value of Sidutan watershed and Reak watershed. This is Sidutan watershed and this is Reak watershed. And the conclusion is the relation between the value of river regime coefficient with the value of runoff coefficient in Sidutan watershed obtained the equation is y is minus e minus 05 x squared plus 0.0048 x minus 0.0537 with the determination coefficient of R2 in 0.8836. And the next is from the Reak watershed, the relationship between RRC or TRS is the same like RRC atau regime river coefficient value with C value obtained the equation like this with determination of coefficient of R2 0.7855. And from this conclusion, the value of RRC in Sidutan watershed and the value of C shows that this watershed is in good condition every year. Reak watershed and Sidutan watershed still show that the condition of the two watersheds are still in the good category. This is the end of our presentation, and thank you very much for your attention. Thank you.